สวัสดีครับ In this chapter we will discuss about the simplest motion of an object, which is the motion in one dimension. We will first define the quantities of motion. Those are the position, velocity, and the speed, which is the first section in this chapter. Since the velocity and the speed are the rate of change of the distance with time, with time on a finite time interval, we will define the average. We will define the average value of those quantities. I mean the average value for the velocity and speed. Average value of the velocity and speed. Next, use the concept of infinitesimal time. We will define the instantaneous velocity and speed. This instantaneous velocity and speed will give us more detail, the detail at any instant of time of the velocity and the speed. The average value will give us only the average of the speed or the velocity in a finite time interval. Okay, but the instantaneous velocity will give you every instant data or information at every instant of time. Okay. Once we have those definition, we move to the simple model of particle under constant velocity. We will do the analysis of this problem. Next, what happens when the velocity changes in time? We will define the acceleration, which is the rate of change of the velocity. Okay. And we will discuss how to represent the change of this quantity in time. That is the change of the velocity, the change of the position, and the change of the velocity. One way to do that is to draw the motion diagram, which will help us to see the picture of our problem. We next analyze a little more complicated model, that is the model of the particle under the constant acceleration. Okay. And we apply the result to the free fall problem. The free fall problem is an example of the motion under constant acceleration. In this case, the acceleration is the gravitational acceleration, or what we familiar with the symbol G. And finally, we end this chapter by repeating previous calculation using calculus. You can see that life is much easier if you can use calculus. So you need to be quite good math to study physics. And before we go on, let me introduce you the concept of the particle, because we will use this concept throughout our study. We define the particle as a point-like object point-like object. When we say point-like here, it means that we don't interested in the internal structure of the object, or we may say that the internal structure of the object has no effect on its motion. So, when we describe the motion of the particle, we will look at the position of the object only. In physics, we use the concept of particle to the motion of the object that its size is much smaller than or the corresponding length. Okay. Every object has size. Even the very small object like electron still have size. The point is that if the motion, if the size of the object is small compared to other distance, the size will not affect the motion of the object. So we need to know the position of the object only. We don't have to know the internal structure or the size of the object, and we can use the concept of the particle here. Okay. For example, we can consider the Earth as a particle orbiting around the Sun. Because the size of the Earth is much smaller than the length of the orbit. Okay. If we look at the Earth, if we have the Earth here, and we have the Sun here, and if we measure the size of the Earth, the diameter of the Earth, okay, just measure the radius of the Earth. Okay. And if we compare it with the radius of the orbit of the Earth, we can see that R is much larger than RE. So, the internal motion of the Earth, for example, the spinning of the Earth, the tilt of the axis, will not have the effect on the motion of the Earth around the Sun. So, in this case, we can say that the Earth is particle. Okay. So this is an example of the concept of the particle. We don't have the real particle in nature, but in many cases we can use the concept of the particle to describe the motion. Okay. Now let's go to the detail. We first need to define the position, the velocity, and the speed of the object. Okay. First, the position. The position of a particle. Remember that here we will use the concept of the particle in our study. So, when we talk about the position, the position is defined as location of the particle. Location of the particle with respect to a chosen reference point. With respect to a chosen reference point. Okay, and these reference points we can use it as the origin of the coordinate system. Okay, so that is a definition of the position. In this slide, we can see three ways to represent the position of an object. First, we call this the pictorial representation. Pictorial representation. That is, we draw the picture of the object on a scale that we use as the coordinate system. In this case, you can see that we can use this point as a reference point, and also it's the origin of the coordinate system. So this is a pictorial representation